Hello students, in this lecture we will see one more numerical on mesh analysis. And now in this numerical you can see a current source has been introduced. In the previous lectures we have seen mesh analysis numericals but using only voltage source and resistances. Okay, so we'll proceed for this numerical. The problem statement is find the current through 2 ohm resistor, and 2 ohm resistor is over here. Now you can easily see there are 3 meshes, so I will assign the 3 currents over here. Of course, I do not look at the polarity of the sources. So here I am assuming current I1 to be in clockwise manner, I2 over here in mesh 2, and I3 over here. Okay, I1, I2 and I3. Now you can't apply KVL in mesh 1. Why? Because there is a current source. So whenever current source is there, you can't apply KVL over here. So how to write down then equation from mesh 1? So you can write over here from mesh 1. I am not writing KVL inversion, I am just writing from mesh 1. Now if you see this diagram carefully, 6 ampere is going up as mentioned in the problem, and you have assumed I1 in upward direction. Okay, that means I1 which is going up is nothing but 6 ampere. Okay, and this is my equation number 1. Of course I will write down this in nice format, but before that if they would have reverse the direction of 6 ampere, let's say downward, then this would have been I1 is equal to minus 6 ampere. But right now I1 6 ampere is going up, I1 is also going up, so I1 is equal to 6 ampere. And what is the equation? So this equation lead to 1 I1, there is no I2 over here, so 0 I2 plus 0 I3 is equal to 6, and this is my equation number 1. Somebody may say that we'll apply KVL over here and then we'll substitute the value of I1 is equal to 6 ampere over here, and we'll have two equation, two unknowns, and two unknowns will be I2 and I3. But what is the problem? There is a possibility of error when you are substituting the value of I1 is equal to 6 ampere and further you are simplifying the thing. Here what I am suggesting, you keep this thing as it is, you go for 3 equation, 3 unknowns, one can easily solve using calculator. Now KVL in mesh 2, so that is up to you, okay, how you are preferring to solve this numerical. So KVL in mesh 2, but before applying KVL in mesh 2 you need to assign the sign for the voltages developed across the resistance, and there is no current source, we can easily apply KVL in mesh 2. So I am starting at this point, so here I will have 36 minus 12 times I2 minus I1, okay, go ahead over here, so I will have minus 6 times I2 minus I3, and that is equal to 0. So here I will have 36 minus 12 I2 plus 12 I1 minus 6 I2 plus 6 I3 is equal to 0. So I'll arrange the terms in such a manner that the coefficient of I2 it turns out to be positive. So it leads to minus 12 times I1 plus 18 I2 minus 6 I3 is equal to plus 36, and this is my equation number 2. And equation number 3 I will get by applying KVL in mesh 3. So KVL in mesh 3. But before applying KVL, you need to assign the sign for the voltages developed across the resistances. So these are the polarities. So I am starting at this point. So minus 3 times I3, minus 2 times I3, minus 9, minus 6 times I3 minus I2, and that is equal to 0. So I will have minus 3 I3, minus 2 I3, minus 9, minus 6 I3 plus 6 I2 is equal to 0. So I arrange the term such a manner that the coefficient of I3 is positive. So here I will have 0 times I1 because nothing is shared with mesh 1, so 0 times I1 minus 6 I2 plus 11 I3 is equal to minus 9. You can see here from this equation also we will get this. So there are 3 equation, 3 unknowns, just I will write down over here. So from equation number 1 I will have 1, 0, 0, and here I will have I1, I2 and I3, and that is equal to 6. Okay, so this is from equation number 1. From equation number 2, I will have minus 12, 18 minus 6 is equal to 36. and over here I will have 0, -6, 11 and -9. So you have 3 equations and you have 3 unknowns, and that is a fair thing in mathematics. One can easily calculate these unknowns. Now one more thing, whenever you have a current source in the circuit, this resistance matrix, of course this is the resistor matrix, it will not be a symmetric matrix. Remember this thing. When you have only voltage sources and resistances, then you can have a symmetric matrix over here. So remember this thing. So I1 turns out to be, once you solve, I1 turns out to be 6 ampere. You can check this thing. Of course we have I1 is equal to 6, but again from the calculator you will get this thing. I2 it turns out to be 7 ampere and I3 turns out to be 3 ampere. But the problem is not over yet. You have to calculate current through 2 ohm resistor. So here I am writing current through 2 ohm resistor is nothing but, it is nothing but I3, and whenever you are writing I3, so through 2 ohm it is moving downward. Through 2 ohm it is moving downward. Here don't mark clockwise, anti-clockwise. According to the orientation of the resistance, we have to mark the sign either upward or downward. So here it turns out to be 3 ampere downward. Okay. If they ask you to calculate current through, let's say 12 ohm, so current through 12 ohm, so you decide whether you are moving downward or upward. Let's say if you have decided to move downward, okay, don't look at these values, downward, then current through 12 ohm will be I1 minus I2, and that of course it will be downward, and that will lead to 6 minus 7 downward, so that is minus 1 ampere downward, so it is equal to 1 ampere upward. Okay, so that is all about the mesh analysis, numerical number 7. Thank you.